Alright, hello and welcome to another one-on-one physics lesson with Dr. Johnny IELTS. Sorry, I'm Dr. John Tran Science because I have five channels, so I'm confused sometimes. So in this video, I and my student Anne, we are working on learning activity 4.5, using electricity wisely. So please read energy usage. Can you? Mr. Anne, please, can you read it?
Energy usage.
Yeah.
Electrical energy is
I
different
don't know
from
why, but your voice is too small. Why? It's not so
really.
loud. It's not so loud at all. Try again.
Electrical energy is different from other form of energy.
Okay, good.
It cannot okay. It cannot be easily stored in large quantity.
Quantities.
That means electricity need to be produced on
Produce
demand.
on demand. Yes.
There have been to be enough production facility and material to meet the province energy need at peak time. If more than enough electricity is produced,
Some can be
some
sold.
can be stolen, though the North America electrical grid outside Ontario.
Mm-hmm.
The grid is used to buy, sell, and transmit electricity from power station, such as the one at Niagara Falls,
Mm-hmm.
to wholesale distributor, such as Toronto Hydro, the largest the largest municipal electricity distribution company in Canada. If there isn't enough electricity, some can be bought from other supply on this grid. If everyone on the grid need more energy than it's available, however, there could be round out or even blackout.
Okay, blackout.
To access your personal environment pack, including energy uses, complete the following interactive activity. Just
Oh,
take
it's
a
a
quiz.
survey for
Yes,
fighting
sir.
climate change. Huh? Fighting climate
Mm.
change. How often you need to do these things? So basically, it assesses your usage of these services or these activity on a monthly basis to see how much CO2 you're producing each month or something like that.
Survey in this survey you go rules. Driving a car, impact. Cars burn fossil fuel, which means greenhouse gas. These greenhouse gas are leading cause of climate change. Reduction. Walk short distance instead of driving or carpooling or reduce the amount you drive by making one or two stops instead of going out multiple times. Buying recyclable and garbage impact. When garbage began to break down or sit in landfill, it emits routine of greenhouse gas. Failing to recycle lead to an increase of garbage in landfill. Eating red meat, livestock rearing is a major cause of
You know, red
production
meat's
of
like
greenhouse
beef,
gas.
right? Beef and other beef, cows, basically the same thing. Beef, lambs, these are red meat, right? And of course, to
Yeah.
raise these animals, you need to, of course, they produce a lot of CO2 and CH4, methane gas, and these are the major greenhouse gases. So if you eat red
Oh,
meat, you are indirectly contributing a lot to climate change, to greenhouse gases emission and climate change too.
oh,
So of course, beef are actually delicious, but of course, it's bad for the environment, very bad. Meat in general. Mhm.
reduction. Try to eat vegetarian food at least once a week and having meatless Monday. Buying material goods impact why no one why no one is able to to go without buying products. Completely, it's important to keep reduction reduction to buy things secondhand or what using a computer, tablet, or television impact watching television or using a tablet.
When you use every device, actually it eats up a lot of electricity. So
Oh,
of course, if you use a bigger TV like plasma TV, very wide screen, it consumes a lot more electricity. And electric power has to come from somewhere, right? Either fossil fuel or alternative sources. But most likely fossil fuel, because I think I told you before, fossil fuel, they when it burn, it produces a very large amount of electricity, so it's very
oh,
efficient. So that's why we are still dependent on it. We cannot get rid of it yet because it's so efficient. It produces a lot of electric energy for what we need, even though it destroys the environment. And our needs are just growing every year. It doesn't stop because
yeah.
human just our number is just increasing, increasing, increasing. So
Oh, using cell phone impact content cycle of upgrading your phone is a huge contribute to landfill and more production is needed to create new and cell phones also need electricity for regular charging.
uh-huh.
reductions, use a time of day for going technology free. Not only it will help contribute to reducing your carbon footprint, but it will also give your head a break. Powering the light in your house require a constant flow of electricity. And energy related greenhouse gases account for more than half all emission and are a major contributor to climate change.
Major contributor to climate change.
Oh, just like every day we use some of the things in our need, it's just like
Of
causing
course, we are
some.
increasing in number, and human needs does not just decrease. It normally just increase, keep increasing. Even though it's very small, gradually, but gradually, we just demand more and more. It's a natural thing as a human to just consume more and more resources.
Yeah,
I know it's bad, but still, that's how it is.
that's how it is.
Mm-hmm.
Taking a shower that lasts longer than 10 minutes. Impact. Water scarcity is one of the consequences of climate
Scarcity is
change.
like how rare it is. How rare
Oh,
water is. Basically, water is not as abundant as you think. In Vietnam, actually, there's a lot of water because we are in Southeast Asia and we are blessed with a lot of things that nature gives us. So water scarcity is not exactly a thing in Vietnam. Of course, if you go out of Ho Chi Minh City, if you go out of a big city, and in like rural areas, water scarcity, especially like clean water. Not all water can be used, okay? Clean water. Have you ever seen people having to queue for hours just to bring home water? You haven't, right? You
man.
haven't seen that, right?
What?
No, you
Oh, I've
haven't.
seen
Now you
some.
know that in a lot of rural areas in Vietnam, people have to queue for hours, line up for hours to wait to buy water.
Oh,
It's not that simple.
yeah. Like, use your shower time to take a bath, which use less water. Leaving the water running while you are brushing your teeth or doing dishes. A water faucet that is left running for 5 minutes use as much energy as 60 watt of light bulb
Hmm.
that's left on 14 hours. Reduction. Be sure to always turn on the tap. Running dishwasher. Dishwasher use both hot water and electricity to function. As a result, they contribute to the creation of greenhouse gases during the electricity production process. Running the Doing laundry, you're using both a washer and a dryer. Washing machine and dryer use an enormous amount of energy,
Hmm.
especially if you run the washing machine using hot water, which needed to be heated with electricity. Dryer are also a huge source of energy use.
I told you already in the last lesson that but clothes dryer, they consume a lot of energy.
Yeah.
Washer, laundry as well. So basically, if you use these things, oh my god, you are using up so much electricity, and that means like you need to burn up a lot of coal, fossil fuel, or petrol.
Petrol fuel.
Eco-friendly dishwashing soap. How about not using the dishwasher at all? Wash by hand.
Hmm. Yeah,
Seriously,
definitely.
if you live alone, you don't have that much dishes to wash. So basically, just accumulate for like whole day, and then you wash it at night with cold
Oh,
water. Then cold water doesn't consume that much electricity at all. It's just cold water, you know. But if you use hot water, of course, it consumes a lot of electricity to heat it up. But if you don't use if you just wash by your hand, you are using your own energy. You don't use the energy of electricity, you know. And so by that way, you're actually exercising and you are helping to save the environment.
that's
If you
cool.
clean if you wash your own dishes. But of course, it's not the best idea because of course it's tiring, you know. But at least you have some form of exercise.
Yeah,
Doing housework is actually one of the best form of exercise.
in your car, ideal when not driving. Dutch average Canadian and ideal car. Flying an
Letting your car
airplane.
idle when not driving. Like
Yeah.
it's basically if your motorbike is just basically it's still on when you stop. Of
Oh,
course, it still consume like some energy too. So idle the car 5 to 10 minutes per day. Huh. You drive a car with a fuel injected engine, letting the engine idle for more than 10 seconds, burn more fuel than turning your car up and restarting your engine. Hmm. So it means if you let it like operate, boom, 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 it basically eats up more energy, more
fossil
fuel.
fuel.
Then you just turn it off and restart your engine.
Oh,
Turn off the car whenever you're waiting more than a few seconds. Hmm. I was thinking about riding a bicycle.
riding bicycle.
Yeah, like when I was a student, so I can exercise more. But the thing is,
But
it's not
that's
that practical because it would consume so much of my time, and time is money. Time is money, of course.
yeah. Last one. Buying good that come in plastic container or aerosol can. Is that how it's called? Aerosol cans. Many aerosol can contain polychlorinated PCB, which are highly toxic and harmful to the environment. Plastic bottles are made using petroleum, which contribute to increased and carbon dioxide in the atmosphere. Ensure that you are buying good product made from recycled plastic or look for eco-friendly goods made from compostable paper and plastic foam. Fighting climate change. Instruction. Complete the environment survey.
Fighting climate change. How do you fight it? Hmm. It's fun. It's fun to fight, but you're not winning. Well,
How often do you falling on
how often do
money?
people win a fight against climate change?
How often do you do the following on a monthly basis? Driving a car. I don't have a car.
Throwing recyclable in the garbage. So it means like you throw things that should have been recycled in the garbage. Like for example, what is recyclable? Like for example, electric equipment. What else? Hmm. Paper,
Paper.
fabric, like clothes things. You can recycle it, but you throw it away anyway. So
Or recycle. I rarely do it.
you should read meat very frequently. I'm sure.
Frequently. It's just a common thing. Like
Red
it's
meat
just
is
so good.
beef, and then what's that? Beef and lamb. Yeah.
Lab. Buying material good. Like, I don't even have money yet.
What? Buy material good. Of course, when you start to earn, you will start like buying just a lot. I'm sure
Like
because I
spending.
was one. When we have money, we'll be like, oh my god, I'm invincible now. I should buy now. It's like that. It's not a good thing, I know, but
And using a computer, tablet, or television. Always.
of course because you're learning online.
Using a cell phone. Always.
Mm-hmm.
Unless your parent just like smack it. Using light or other electrical household device. Always. Taking a shower that lasts longer than 10 minutes.
I took
Frequently.
like 15 minutes shower, 20 minutes. So because I need to make sure that everything's clean thoroughly. It's better than to have some of the soap on your skin and then it irritates later. You have to wash it again anyway. So it's better to be safe than sorry.
Yeah. Even though water running while you're brushing your teeth. Really. Running the dishwasher. I don't have one.
You might have one in the future.
Well, maybe. Unless doing laundry using both a washer and dryer frequently.
Oh, of course, because everyone have the washing, so you have to use it anyway. Can't escape from it.
Letting your car ID when not driving? Nah, never.
Flying
Flying in
an
an
airplane,
airplane?
rarely, right? People rarely go to on airplane. I mean, at your
Yeah.
age.
Well, I've been onto an airplane, but like just like during this time, like COVID is around, it's hard to like travel
Oh,
anywhere
it's hard to travel in this COVID time. This is fact. Yeah.
using paper product frequently. Is it always or just
I think it's always because every day you work with books and things like that, so you're using paper products all the time. So that's why you see, I'm trying to reduce. I'm trying to reduce by using electronics, which will of course damage the environment in a different way, but at least it's less damaging because it lasts longer. It lasts longer. It's less damaging to the environment. The longer you keep it, the less damaging it is to the environment.
I'm good that comes in plastic container or so can. I don't have money yet, so it means never. Is
Electricity costs, of course. Now, time to face the payment. The more you use, of course, the more electricity you have to pay. It's a given fact. And
example
yeah, let's just
electricity
do some examples.
bill.
There you go. Can you make it bigger?
Let
Uh,
me zoom in.
zoom it in, yeah.
Is
There you go,
that
this is
enough?
a bill. Oh, kilowatt consumption of 351 kilowatt. And each kilowatt is how much? Ah, so they calculated off peak and mid peak on peak. So basically, at peak hours, of course, the electricity would be the most expensive. So that's why you see on peak it's like 0.20 over there, uh, $0.208 on peak. Mid peak is like at the middle of the peak, it's like 0.144. Off peak is like it's like midnight or something like that. When people don't use that much, it's only like $0.101, right?
Yeah.
So that's the unit price, and times the amount of kilowatt, you will get to the amount of money you have to pay. And of course, delivery also costs money too, $27.79. That's the delivery of electricity. And regulatory charges means like the tax or something that the government is imposing on people that they have to pay. That is $1.67. That's Canadian dollar, I guess. Ontario, yeah, Canadian dollars. Billing adjustment. Okay, Ontario electricity rebate. You know what a rebate is, right?
Yeah, repay.
Rebate means the amount of money they will have to pay back, pay you back, give you back that money.
Oh,
Sale tax. You have to face this thing soon, and then you have a due date.
hello.
There's a due date that people have to pay. Otherwise, cut. Otherwise,
Oh,
there will be power cut off, and you have to pay a fine so that they will restore electricity to your place.
that's a lot.
Is that the whole family? You think so?
Um, yes.
$60 like $60 like 1,300,000 something Vietnam dong. I think it's the whole
Oh,
family, yeah.
yeah.
Or maybe electricity is like cheaper. I don't know. Maybe more expensive in Canada. Maybe
Yeah, I think Canada is more expensive.
could be, should be. But the price of everything is just keep increasing in this country as well. Okay, let's continue.
Series is
Screen
yeah.
reader. Open this accessible alternative. Screen reader is of course what they meant by iPad or any kind of pad. I think. As you can see, there are three different rates depending on time of day. As I told you, on peak, mid peak, and off peak. You know why on peak they have to make the price like 2 times more expensive than off peak? You know why they have to do that?
What is it like when the it's like when the electricity get diverted, like get much more power, like at some point. It's like
Basically,
that.
it's not about that. It's to deter people from using too much electricity in on peak hours. You know, because if
Oh,
they know that on peak, if they use a lot of electricity, they have to pay a lot. Then they would not use that much, and they would try to use at night, something like that. You know, off peak. So it's like it will balance out. You know, the regions of the country. It will balance out the hours. So it's not like some hours like too much, but some hours like too little, you know.
yeah.
So it won't overload the grid. It won't overload the grid. So the whole idea is here just to balance out, so people won't use that much electricity on peak hours, and they will be encouraged to use more electricity during off-peak hours. So that's the idea. Just encouragement, you know, and try to balance things out. But it's not always as simple, because people often work during like office hours, 8 to 5, and that is the peak hours, so they have to pay a lot during that hours anyway. And
Right.
who work at night that much? So it's not that easy. Okay, let's continue.
Calculating energy usage.
Okay, let's study all the way until 1 o'clock something. Okay, our calculating energy usage. Energy equal to P times T. So P is the power rating of your device, and T is how much time you use it. So equal to the amount of energy that you use.
In estimating load, have noticed in the electricity bill, the unit of electricity consumption is the kilowatt hour kWh. Watch the following video.
Of course, E equal to P times T, and P, is actually equal to V times I. So you can get that formula, E equal to VIT, like that.
Oh,
So in the electricity bill, the unit of electricity consumption, it's kilowatt hour. Kilowatt hour. So it has hour in there, which means time. So it means that you take the amount of watt, which is the power of your equipment, times the hour that you use it, you will get to the amount of energy that you use in that month. You have to pay. Okay. Wait, what's that thing? Black, dark thing down there? Video not currently available for playback.
that was the video.
Oh,
I think it's
that's bad.
unavailable.
Oh, that's bad. Is it unavailable in Vietnam something?
No, no. I think they just deleted it or something.
Hmm.
Oh, never mind. No, never mind. It doesn't work. Awesome. Oh, there's a video.
Mm-hmm.
We're going to look at the cost of operating an appliance. The formula for the cost of operating an appliance is cost equals the electrical energy, or E, multiplied by the unit cost of that electricity. We are going to simplify this expression or make this formula a little bit more usable for us. We have learned previously in this course that electrical energy can have a few different formulas. One of the formulas for electrical energy, or E, can be the power multiplied by the time. So we're going to put that right here into our formula to make it a little bit more usable for us. We will then multiply by the unit cost. So really, if we look at what this means, it means that the cost of using an appliance is the amount of energy that it uses. In other words, the power multiplied by the time, and then multiplied by the cost of that power. The cost is a unit cost, so it will be so many cents or dollars per kilowatt hour. We are going to look at an example of this. How much does it cost to operate a 100-watt light bulb for one day if the cost per kilowatt hour is 9 cents? We're going to start by looking at all of the numbers that we've been given, and we're going to make sure that they are in the correct units, remembering that when we're looking at the electrical energy, we're looking at kilowatt hours. Right away, I can see that we're given a 100-watt light bulb. We need to know this in kilowatts. To go from watts to kilowatts, we could divide by 1000 or move the decimal places 3 places to the left. So if I say 100 and I had a decimal there, if I moved it 1, 2, 3 places, I would end up with 0.100, and that's kilowatts. The other thing I could have done is taken 100 and divided it by 1000, and I would have ended up with the same result, 0.100 kilowatts. To simplify the one day, we need kilowatt hours by the time we are done. So we are going to take our one day and convert it into hours. So that's 24 hours in a day. So now I think I have everything in the units that I want. And now we're going to use what we call the GRASS method for problem solving. And so let's get started. G stands for given. What do we already know? We know that power is 100 watts, and now that we've converted it to kilowatts, so it's 0.1 kilowatt. I know that time is 1 day, which is equal to 24 hours, and I also know that the unit cost is equal to 9 cents per kilowatt hour. R stands for require. What do we need to find out? We have to find the cost using the formula P multiplied by time multiplied by unit cost, so that is my formula. A stands for application. What values do we know that we can substitute? For the cost, we know that power is 0.1 kilowatts, multiplied by the time, 24 hours, multiplied by the unit cost, which is 0.09 or 9 cents per kilowatt hour. S stands for solution. What is the answer? Using my calculator, I'm going to multiply decimal 1 by 24 and multiply by 0.09. My cost equals $0.216.
Wait.
S stands for statement. How can we express the solution in a statement? We will say that the cost of operating a 100-watt bulb, which is a common wattage for light bulbs, for one day is 0.216 or 21.6 cents. Now let's put this into a real-world context. We don't usually use parts of a cent, so we can round to the nearest cent, and our answer is 22 cents. That completes our example.
22 cents for a day. So it means in 1 month you should have, say, $6.6 just for a light bulb 100 watts. Imagine how many light bulbs you have in a whole house and other electrical appliances as well. So it adds up to like $200, $300 per month. It's just a lot. So that's why people try to not use 100-watt light bulbs. They use something like 14, 12, 10 watt, but it's called energy saving. Try to save the planet that way. Okay, let's continue. Hello, are you still there? Because you are being a bit slow, so I'm like, what's going on? Let's continue.
As you learned from the video, to determine the cost of operating a load, you need to know how much electricity is used and the cost per kilowatt. Cost of operating appliance. The equation can be written as
Cost of operating appliance. So of course, the higher the power, the more money you have to pay. That's a given fact. So that's why people try to use energy efficient thing.
yeah.
Beside from that, I try to make more money. If you have more money, you don't have to worry too much about saving.
How much does it cost to operate a 100 W type of watt light for one day if the cost per kilowatt is to solve the problem, check your answer. Smart meter and time to use billing. Smart meter have been installed for example, we're doing winter in Ontario in 2017. The first kilowatt user charge at 7.7 cents.
This is a thing that we always see in every houses. It might look a little bit different depending on countries and regions, but essentially it should be the same. You should learn how to calculate electricity. That you have to pay based on these meter, smart meters.
Oh, yeah. Winter in Ontario, first 100 kilowatts.
It's like there's a rule that if you use more than the first 1000 kilowatt hours per month, you have to pay more. This rule is basically to dissuade or to try to persuade people to not use that much
Not
electricity,
oh,
Dissuade,
So
or basically persuade people to not use something. We call it dissuade.
this way.
Persuade and dissuade is a different. It's like opposite. Persuade people to not use that much electricity. So that's why more than 1,000 kilowatt hour, the price increased to 9.0 cents per kilowatt hour. Same thing in summer. Basically, if you use more than a certain amount, you have to pay more. It's like that. This rule is basically to protect the environment, yes, and to basically make people be more aware of the fact that they need to save energy.
Oh,
But you know why in summer the price is much more expensive than like in winter?
why?
Like 7.7 to 10.7 and then 9 to 12.5. So a lot. It's like increased by 30% or something, or even more than 30%, like 40%, something like that. You know why?
So they could
Think about it. Can they make electricity easier in the summer compared to winter? Is it more windy? Is the water flow easier? Uh, is there a lot of rain? Something like that. Think about it.
hmm,
Anyway, in winter, people have to use electricity anyway to heat up their homes. So it's like a given. People must use. So that's why they have to decrease the price a little bit, so that it won't make a huge burden on the people. But in the summer, people don't use that much electricity for heating up things, so the price go back to normal, like higher. So I think one thing could be like to help the people to give some discount, something like that. But another reason could be that during the summer it's actually harder to make electricity compared to winter time. Maybe, I'm not so sure. Let's just read the reason. Just read the thing down here. You can see to
yeah,
encourage
to encourage
use.
energy,
You just read it that thing to encourage.
encourage energy conversion, and peak hour are set the time of the day when people are likely um, to use the most energy. Electricity usually usually around breakfast and dinner speak. It's going to be overnight from 7 p.m. to 7 a.m. as well as anytime on weekend and holiday in summer because of high air conditioning used during the day. Peak period extend for most of the day if you want to save money.
Oh, it's also because in summer people have to use more money, more electricity for air conditioning, you know.
Oh yeah, air conditioning
But
because
in
it's
winter, people
hot.
have to use that electricity for heating. But then the thing is, if you are cold to death, that's worse than if you are sweating too much, right? You can take a shower.
Yeah,
So maybe that smaller price to encourage people to use more for heating and keep their health in check, you know.
so they can just that's just maybe. Ontario electricity time to use. I've used price period, summer weekends, weekdays, midnight.
You
Function
see midnight, noon, peak hours, and then winter week. Okay, summer weekday, of course, peak hours about say noon time, 11 o'clock to 5 o'clock p.m. Like 11 a.m. to 5 p.m. is that summer or weekdays. But in winter weekdays, like the peak on peak is like 7 a.m. to 11 a.m. and another one is like 5 p.m. to 7 p.m. That's when people go to work and get back home and cook dinner and things like that, you know, watch TV, things like that. But then, um, why? Can you answer the reason why the peak hours different from summer to winter? Can you understand? Can you explain why?
So in winters, winter's like much more expensive. Like so,
Think about it. Summer at about 11 o'clock a.m. is the temperature high. It is
Ontario
the
is
highest. It is the highest at that hour, right? So you have to turn on AC, aircon, and also you work a
oh
lot during that hour too until 5 p.m. So that's the peak hours in summer. In the winter, of course, at about noon, the temperature increases, so it's warmer. You don't have to use heating that much, right? So you turn off around 11 o'clock because it's warmer at that time. Can you imagine that?
yeah.
And at about 5 p.m., that's when the sun goes down in winter. So it starts to get really cold, so people have to turn on heating about 5 p.m.
IPN.
Remember, 5 p.m. in winter, but Canada's like it's the sun goes down like already 5 p.m. in Canada. So, but at that time, you have to turn on the heating, and also at that time, people go back home, do washing, cooking, things like that, turn on TV, you know. So that's why about 5 p.m. to 7 p.m. is like peak. So after 7 is like dinner's is done, it's done, and people don't, and the heating is already like being used. So it's just keep dragging on, you know. So it's off peak now. How about weekend and holidays? Weekend and
Weekend or
holiday, we
holiday.
don't go to work, right?
Yeah, it's like
We
a
just stay
break.
home, and then the whole day is just like off peak year round. When we go to work, actually, there's a lot of electricity is used to operate equipment and things like that in the office. So what's the solution here? Probably people should have holidays and weekend all the year round, and not having to go to work
But
to save
having
electricity. Oh, I think working from
to
home is a good idea. To save electricity because we don't have to commute to work. No more exhaust gas being pumped out. No climate change. And when we work from home, it's like the amount of electricity we use, just like similar to the night or something like that. Quite similar. So it's all off peak. To be honest, if people work from home, actually it saves the environment more.
yeah,
But
well,
it's only
thanks to
good for
COVID.
introverts, not good for extrovert.
Yeah.
Extrovert people didn't
Are you
have a
more?
need to just go out and about and meet people and then use up electricity.
The efficiency of appliance. The
Mhm.
function of any load in the circuit is to convert electrical energy or potential difference into another form of energy, usually heat, light, or mechanical energy. The efficiency of these conversation is never 100%. For example, energy in the form of heat is always lost to the surrounding during the transfer process.
Mhm.
It is possible to calculate the efficiency of an electrical appliance by measuring the amount of electrical energy that enter the appliance input energy and the amount of energy used while the appliance is working output energy. The ratio of these two measure in the difference in the efficiency. Multiplying this ratio by 100 gives you a percent efficiency.
Mhm. So how efficient your appliances are? Some appliances like they receive 5-star efficiency, something like that. So what does that mean? Let's read this one. So
Sure.
if the amount of input and output energy they compare that. So basically, input energy is the amount of electricity that you have to use, compared to output energy is the amount of energy that actually do work, actually useful. So let's say if your device is very old, you have to put a lot of input energy for it to work, but then it doesn't produce the desired result, doesn't produce that much desired result that you want. So it's not so efficient, right?
Yeah.
So try to use newer device. Even though, of course, they are more expensive, but still they save you energy in the long run. Like for example, if I use a older laptop, I have to pay more money during the like many years compared to if I upgrade to new laptops. And also on top of that, I'm using new things, so I'm advancing. You know, this thing applies to a lot of things, like stove, microwave oven, fridges, laptops, dishwashers, washing machine, something like that. Same thing. The newer the technology is, the more the efficiency. But the thing is, you can never have 100% efficiency, you know, never. We can get close to that, very close to 90, 80 something, but never really close to like 100. It's almost impossible, you know. There has to be some energy that is wasted to this environment, you know.
Oh,
Like as heat, for example. Like for example, light bulbs. Even though it's say energy saving light bulbs, 10 watt that can shine as bright as 100-watt light bulbs. They can say like something like that. But the thing here is, even though it saves you energy, some heat will escape to your environment, to environment. You cannot prevent it. So you can never have 100% efficiency. Okay, let's just read things here. Consolidate knowledge.
in this calculation, the unit of energy you will be using is the joule. You will use the equation E, PT equal PT is calculate electrical energy joules, but in this case power is measured in watts, not kilowatts, and time is measured in seconds, not hours. One joule is equivalent to 1 watt second. A watt second is the energy equivalent to the power. 1 watt obtained for 1 second. As a result, the equation is 1J equal 1 watt.
Okay. Talk about joules and things like that.
Yeah. Example, energy efficient of a kettle. One of the easiest applications to use in efficiency calculation is the electric kettle. Information needed to perform the
Oh my
calculation.
god, I know it is 1300 watt. About 3.5 minutes to heat up the water. Oh, 3 minutes 24 seconds. I understand now. It's just to heat the water into like to 65 degrees Celsius. It's not to boil the water. That's why it's only like 3 minutes 24 seconds. Normally, it takes me about 5 minutes to heat it up to 100 degree and boiling, you know, to make tea. Oh, 1 kilogram water is like 1 liter. For water is special. For 1 liter, 1 kilogram of water, actually it's exactly 1 liter of water, you know. That's for water only, okay? Energy efficiency in the kettle. But I think the kettle actually, a lot of heat is produced, but a lot of heat is escaped to the environment too.
Efficient. And for
Okay, let's try
detail,
calculating efficiency of appliances, energy efficiency of a kettle. Yeah.
watch the following video.
In this video, we are going to look at calculating the efficiency of an appliance. The function of any load in a circuit, any appliance in this case, is to convert electrical energy into a different form of energy. Sometimes that other form of energy is heat, sometimes it's light, sometimes it's mechanical energy to make things move. Those conversions, for example when a lamp is converting electrical energy into light energy, are never 100% efficient.
There you go. That's what I
Energy in the
told
form
you.
of heat is given off, which is why light bulbs feel hot. They're not converting all of the energy properly, some of it is lost as heat. You can calculate the efficiency of an appliance if you know the amount of energy going into the appliance, or the input energy, and the amount of energy coming out of the appliance, either as light or heat or mechanical energy. Energy efficiency is expressed as a percent. The ratio of output energy to input energy is found by dividing the output energy by the input energy and multiplying it by 100, giving you a percentage which represents the efficiency of that appliance. We will still use the equation for energy, E equals the power times the time, for calculating the input energy, but we will use a different unit to measure that energy. The reason we're using a different unit is because our output energy is not electrical energy, but rather thermal energy. The amount of thermal energy in a system is measured in units called joules, represented by J. 1 watt delivers 1 joule of energy per second. Rearranging this, we see that 1 joule is a watt second. So 1 joule is the equivalent of 1 watt second. That means that all of our calculations must use time units of seconds instead of hours. Now, let's look at this example. We'll use an electric kettle in our example because its function is very simple. Most of the energy that enters as electrical energy is given off as heat to increase the temperature of the water so that it will boil. We're going to use the kettle to heat 1 kilogram of water from 23 degrees Celsius to 65 degrees Celsius. It takes 3 minutes, 24 seconds, or 204 seconds to heat that water. Our solution will have 3 steps. Calculate the input energy, calculate the output energy, and finally, calculate the percent efficiency. We'll use the grass method to organize our work. Let's start with input energy. Many appliances are rated according to the number of watts required to operate them. The power rating of our kettle is 1300 watts. G. We know that for the input, the power rating is 1300 watts. And if you look at the information that we are given at the top, we have the time to heat the water. We know that the time was 3 minutes and 24 seconds, and so we'll convert that to seconds. There are 60 seconds in every minute, so 3 times 60 plus that 24 seconds equals 204 seconds. Our total time is 204 seconds. R. We are required to calculate input energy. In order to find the energy, we're going to multiply power by time. A. For our application, we'll substitute in everything that we know. We know that power is 1300 watts and that the time is 204 seconds. S. We'll get our solution by multiplying those quantities. 1300 watts times 204 seconds gives us 265,200 joules. S. So, our statement is that the amount of input energy is 265,200 joules. Now let's look at the output energy. Okay, so we know how much energy went in the water, but let's look at how much of that energy actually heated it up. So what we are actually calculating for output energy is the amount of energy that goes into heating up the water from 23 degrees to 65 degrees. We will need a different formula, one that you may not have seen yet.
This is a
Our
new
output
formula
energy
now.
is equal to the mass of that water in kilograms times the temperature change in degrees Celsius times 4,200 joules per kilogram degrees Celsius. That number, 4,200 joules per kilogram degrees Celsius, is a constant that is always used for water and is called its specific heat capacity. So if you're ever calculating the amount of energy going into changing the temperature of water, you would use that constant right there. Other substances have different specific heat capacities. G. Okay, so let's go through our given. We know that the mass is 1 kilogram. The water temperature started at 23 degrees Celsius and went up to 65 degrees Celsius. 65 subtract 23 is 42 degrees Celsius, so our temperature change is 42 degrees Celsius. R. We are required to calculate output energy, so our output energy is equal to mass times the temperature change times 4,200 joules per kilogram Celsius. A. For our application, we'll substitute in everything that we know. Output energy will equal 1 kilogram times 42 degrees Celsius times 4,200 joules per kilogram degree Celsius. S. If we multiply all of those together, we get that the energy is 176,400 joules. S. So, our statement is that the amount of output energy is 176,400 joules. Now we can calculate the percent efficiency. We've done the two really hard parts, so let's finish this question. We know that input energy is 265,200 joules and output energy is 176,400 joules. We are required to find percent efficiency, which is equal to output energy divided by input energy times 100. So, 176,400 joules divided by 265,200 joules times 100 equals 66.5%. So, the kettle is 66.5% efficient, which means that it's only making good use of 66.5% of the energy it's bringing in. The rest is being lost, probably due to electrical resistance and to heating up the kettle itself. This percent efficiency value sounds about right.
So it's a three-part question. It's a three-part question, you know.
Yeah.
So you have to find like input, output, and then put in the equation, a three-part question. So input, output. So they use two different equations, and then efficiency as a third equation put into the thing. All right, 3 steps. Let's try to use this one. Let's try to look at this one once again, okay? There you go. Okay, that's just like seeing the steps here. And then finally efficiency. Okay, it's good to remember the formula so you can just put it in. But when you see the formula, you have to be careful with units. If it matches each other, then you know that you don't have to change unit anymore. But most of the time, you have to change the unit.
Do the following calculation.
Okay, efficiency
using
here.
yeah. Mass of water. Calculate. Ideas for your energy usage. Ideas for reducing energy usage. Use low of clothes and dryer. Keeping refrigerator and freezer door shut.
Full load of clothes and dryer. Remember, if you have to dry like a whole full load or half load or just a quarter load, the heater, basically the dryer, still have to use that much electricity to heat the whole thing up. So it still have to use the same amount of input energy. Anyway, so full load of clothes and dryer is still a way better way to use efficiency, the dryer, you know. So washing machines, the same thing. It doesn't matter if you wash like a full load or half load or something, but still you need to do it full load to save energy, you know. They said something about oversized load. So if you put too many in the machine, sometimes it won't work, and the clothes won't even dry properly. So too much of a good thing is not that good. So be careful. Just full load, but not oversized. Don't overdo it, you know. Okay, and keeping refrigerator and freezer doors shut.
Thermostat.
Thermostats. Beep, beep. The thing that people use at home. So basically, you can control the air conditioner in summer and control the heating in the winter more efficiently. Hmm. So basically, furnaces, they circulate the warm air inside the house because you're inside the home already. You breathe out CO2, right? And CO2 is like it keeps the heat inside the home. So basically, furnaces they say that drive a fan to circulate the warm air inside the home. But then air cons basically they use to cool the air and to drive the fan. So two things at once. It has to cool the air and drive the fan to circulate the conditioned air to the house. So it do two tasks at the same time. So basically, air cons it takes more energy than furnaces, you know. So basically, if you decrease the use of your air cons, air conditioner, you save more money, more energy by decreasing the use of furnace. That's what they say.
Yeah. Oh, appliance such as
There you go.
refrigerator.
Old appliances actually, the older they are, the more they cost energy to operate. So it's not always good to hang on to like old stuff, old thing, you know. People think that
Yeah.
they might save money by not buying new thing, but actually they are wasting energy too. They are wasting their money too by doing so. Ironic, right?
Yeah.
It's quite ironic to think about it. We try to save our money by not buying too much, but the problem is our old things actually consume more electricity than when we thought. And the older they are, the more electricity you waste by using them. Quite ironic.
Very.
So getting rid of old appliances is a necessary step. You know where they get it. You know where they throw it to. They can try to sell these things to third world country like Vietnam, Thailand, or something like that. We are no longer third world country. We are the middle country now. But
What's middle?
we used to be the place that you know. We used to be the place that buy
Like very
like
poor?
old things from like first world country. You know, we're still doing it, but still things are changing. So instead of throwing away those things in landfills and garbage dumpsters, um, At least they can serve someone, even though it costs more electricity to work. All right. Now compact fluorescent light bulbs. These are energy saving light bulbs, you know.
Yeah. Individual light bulbs do not use much.
Okay, LED. We're talking LED now. LED.
LED.
LED light emitting diodes. Basically, they are small little lights like that.
Oh, so
The same amount of light. LED are actually very expensive, but then they don't consume that much electricity, and they save you energy in the long run. Operating costs incandescent is like highest. Compact fluorescent and LED. That's more than 5 years. Wow. 50,000 hours continuous use. So every year is like 10,000. And divide by 365. And that's about how much? 10,000 hours. Let's say 10,000 hours per year. Divide by 365. That would be about 27 something hour per day. That's impossible. That's the same more than 5 years. So let's say 50,000 hours
50,000.
divided by, let's say, 6 years or 10 years. Let's say 10 years. So 5,000 per year divided by 365 days. That's about 14 hours per day. Wow, that's a lot. Like 10 years LED lights. Very efficient converting electricity and light. Their price have been dropping rapidly, even though they are very expensive to buy. Indicator light on appliances and vehicles since 1960. Usually being used in television and computer screens.
Performing a function. For example, do you leave your phone charger plug into a wall outlet even when your phone isn't being charged? The charger is the phantom. It uses electricity whether it's charging your phone or not. You can see less electricity and save a bit of money if you unplug the charger for battery, phones, camera, and computer when they're not in use. Although the individual amount of electricity are not very large, they could add up if
And the number
A
of
number.
charger left on all the time.
Other examples of phantom load include a feature of most electronic devices enabled by standby
Standby
power.
power, standby mode. When you don't really use them, you put on standby mode. So when you turn on, you use them again, it's very quickly, it can just operate again quickly. You don't have to warm up. So when you turn off one of these appliances, it isn't really off. It just sleep a bit and then wake up again, and then you don't have to wait for it to warm up. But then of course, everything has a price to pay. Some
Yeah.
power is still going into it. So it's like if I just close my laptop this way instead of like shutting it down, maybe okay, it still use a lot. It still use some phantom load, still use some electricity to keep it like not really sleeping. But when I turn it on again, I just flip it and then turn it on immediately. I can work. I don't have to wait for it to restart things. Alright, I think, is there any more other thing?
Yeah, there's a bit, but I can just read
Okay,
them.
transferable skills. Oh, average salary and work environment. Electrical engineer, physiotherapist, career, connection to electricity. Why they're talking about career at this part? I don't understand. Can you go down? Hello?
Yeah.
Can you go down, please?
Yeah, sure.
Oh, they talk about like career with electricity.
Yo.
Okay, you can read this thing on your own because it's not really exactly related to physics now. It's just career path. Okay, I'll see you then.
See you.
Monday, remember, Monday we don't study, okay? So
Yeah.
Tuesday, and then
Tuesdays,
Wednesday, maybe
Wednesday.
Wednesday we learn math then. Maybe if you want to,
Mm.
you can use Tuesday math, and then Wednesday science, and Thursday science, Friday science. Okay, let's do Tuesday math then.
Okay.
Okay. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh cái đăng ký kênh đó để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.